going to be able to identify functions as well as identify families of functions and their parent functions and equations. First, we want to talk about what a function is. Well, if you have a function, it means that every element of your domain has exactly one element in the range, which essentially means each x value has its own y value. If you have an x value that has two different y values, then we do not have a function. We don't have something that functions well. A simple way to check for something, if something is a function, is called your vertical line test. Your vertical line test says if you have more than one point that passes through your vertical line at a time, then the picture you have is not a function. Let's start with this linear graph over here. Okay, so if I pass my vertical line across this graph and it only hits in one spot at a time, this would be considered a function. So I'll set here, 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 here. Yeah, we're good all the way down. So this graph would be a function. The problem arises if we have another point. Maybe I have a point right there. So if I do my vertical line test now, at this spot, at this specific spot, my graph crosses through my vertical line here and here. So it's failing the vertical line test, which means this would not be a function. Let's check out the second graph on the right. Oops. I can get my line. There we go. Oh my goodness. Hold on. Here, if I grab this vertical line, if I pass this through this quadratic function, this parabola, it again only crosses through one point at a time, so that would be considered a function. Sometimes we'll have to look at it differently. For example, if you just have a relation, a set of ordered pairs, we have to make sure each x has its own y value. Here there are no points that are one above the other, so it would pass our vertical line test. So yes, this would be a function. On the right, again, we have this parabola-looking shape. So when you pass your line through, it only hits in one spot, so that is also a function. If it's not on a graph, we can't use our vertical line test. So we want to look at a mapping. Every x can only have one line coming from it. Every x can only have one line coming from it. So in the first one, -1 has two different lines. We end up with the point -1, 4 and -1, 5. If I graphed this, we would have 2 points, one above the other, which would not pass our vertical line test. So because of that situation right there, this is not a function. In number 4, a new vertical line here. Oh, it's not as vertical as we'd hoped. Hold on. That's a little better. If I use my vertical line test here, we're okay here, and right here you have 2 points going through that line at the same time, so that is not a function. On number 5, if I take my vertical line and drag it across, here my vertical line completely overlaps the other vertical line. So that means that every single point is one x value with a bunch of y values, and that makes it not a function. So we have a no over here and a no over here. Finally, if I use my vertical line test on this one, we are safe all the way across. So 6 is a yes. Now let's look at a set of ordered pairs and see if we can determine whether or not this would be a function. In order for it to be a function, remember every x must have its own y value. 4 has a 2, 2 has a 3, and 6 has a 1. Since there are no repeating x's, it is a function. Every x has its own y. In number 8, negative 3 has 2 different y values, making it not a function. And in number 9, different x values, different y values. Even though we have the same y value, 0 and 0, those numbers are spread apart, so it would still pass our vertical line test. So y's can be repeating, x's may not.